Okay, so in this section we're going to look at distance traveled. Now we did this when we did derivatives, but now we're going to look at it from an integral standpoint. And this is this is a very important topic in calculus, which is why we look at it twice. So what I want you to recall is that if we're given f of x as the position function, then the derivative of that is the instantaneous velocity, and the derivative of the velocity is the acceleration. And remember, speed is the absolute value of velocity. Well, now we're sort of going backwards. So if we're given acceleration and we integrate acceleration, we get velocity. Notice we have to add the initial velocity. That's our plus c to get our final formula for velocity. And then position, we would integrate velocity to get position. So when we were doing derivatives, you recall I would call it PVA, position, velocity, acceleration. But now when we do integral, we move backwards. So we start with acceleration, we integrate, we get velocity, then we integrate that and we get position. Notice that on both of these, we have to take into consideration the initial value. This is at the bottom of your notes. We're going to talk about displacement versus total distance travel. You have to recall that integration is the area under the curve. So to find displacement from the velocity, we just integrate the function. The negative areas we consider negative, the positive areas we consider positive. So displacement is simply the integral from A to B of the velocity. However, total distance traveled, we have to take into consideration the negative parts of the function. So when we look at total distance traveled, we take the absolute value of the velocity function and then integrate it. If we have a calculator, and I will show it when we get together, I'll show you how to do that on your calculator. If you don't have a calculator, you have to divide the function into by its roots to see when its values were positive and when it was negative. And of course, we're going to do an example of that. Now, let's take this example. We have a honeybee, and it's making several trips to its hive. Now, we have to remember that integration is simply area under the curve. So our question is, we're given the velocity graph as shown below. And we want to know the total distance traveled by the bee. So to find the total distance traveled by the bee, and we're given the velocity graph, we have to integrate that graph. And so this is just the area under the curve. So to find the total distance traveled, we have to take the absolute value of the negative distance traveled. So this area under the curve from 0 to 2 minutes is 200 feet. That's a positive 200 feet. And then from, it looks like from 3 to 5 minutes, he traveled another 200, but this time in the negative direction. So you have to look at this as that the bee left from the starting position, went to the hive, and then flew back. So when we're looking at the total distance traveled, he actually traveled 400 feet. Then he travels once again. So now he's traveled a total of 700 feet. And then he traveled a total of 100 feet. So when we're looking at total distance traveled, we have to take the absolute value of the negative distance when he was traveling to the left. We have to take the positive of that. So the total distance traveled would be 700. Now, if we're looking at displacement, then we look at that differently. So his displacement in the first 2 minutes, his displacement was 200 feet to the right. Then after the next 5 minutes, his displacement was actually 0 because he flew to the hive and then flew back to his starting position. So his displacement is 0. After the next 8 minutes, his displacement is 200 feet. And then he comes halfway back, so then his displacement is 100 feet because that's how far he is from where he started. So now let's look at a turtle, and we have a similar suggestion. He starts 2 feet to the left of the mailbox, and then he travels for 10 seconds. So the first question we ask him, what is his displacement? Okay, so how far is he from where he started after 10 seconds? So he traveled, and to figure out how far he traveled, we have to find the area under the curve. And to do that, this is a trapezoid, so we have to use the trapezoid formula to figure that out. And if you recall, the formula for a trapezoid is 1/2 base 1 plus base 2 times the height. So in this case, our base 1 is from 0 to 5, so our base 1 is 5. Our base 2 would be 1, 2, 3, 3. And our height is 1, 2. So to find the area of this curve would be 1/2 times 5 plus 3 times 2. What is that? 8? Because that's not what I got. I got 7. How did I get 7? I got 7 and 14. So I did something wrong somewhere. Did I count wrong? I think I counted wrong. I think this should be, oh yeah, this is 1. I'm sorry, I counted that. This should be 1, 2. So that's 2. Sorry, which would make that 7. I can do math, I just can't add. So that the area under this curve is 7. And the area under this curve, if I did the same thing, base 1 is 1, 2. So I have 1/2 times 2 plus 5. And the height is 4. So this would give me 14. So this area is 14, this area is 7, and it's negative because it's under the curve. Okay? So if I want to know the displacement of the turtle, I would say, okay, so from where it started, even I know it started 2 feet to the left, but we don't consider that when we're looking at the displacement. So from where it started to this point, it traveled -7. And then from this point to this point, it traveled +14. So its displacement would be -7 plus 14, which is 7. If I want to know the total distance traveled, so the bee traveled, or the turtle traveled these 7 feet, even though they were in the left. So you have to look at it this way. You travel 7 feet from where you started, and then you forgot something, so then you turn around and you go back 14 more feet. So your total distance traveled here is 21 feet, or 21 units. Okay? What is the position of the turtle? Well, the turtle started 2 feet to the left, so it started off at a -2. And then it traveled a -7, and then it traveled 14. So the position of the turtle is 5 units to the right of where it started. Okay? I hope that makes sense. Okay, so how do we do this algebraically? If I give you a function, which most of the time you'll be given a function, and you're asked to find the net, which in this case is the displacement, and the total distance, how would you do that? Well, to find the net distance for the first 3 seconds, we simply just integrate it, as we said before. So I would just integrate this from 1 to 3 and integrate the function. So if you recall, this will give me 1/3 t cubed minus 7/2 t squared plus 10t. And I would evaluate that from 1 to 3. So what is that? 27/3 minus 63/2 plus 30 minus 1/3 minus 7/2 plus 10. and whatever that distance is. I'm not going to actually do the math for that, but whatever you would, that would be the net distance. Now, to find the total distance traveled, if we don't have a calculator, so I'm going to show you how to do this without a calculator, and then when we get together, I'll show you how to do it with a calculator. So if we don't have a calculator, what I have to notice is that from 1 to 2, because I just kind of sketched the graph, from 1 to 2, I need to find the area under the curve here, and I notice that that area is positive. And then I have to find the area of the curve from 2 to 3. And I notice that that area is negative. So this is the net, this is the total distance that I traveled. So I have to integrate from 1 to 2, and that's going to give me a positive answer. And then I integrate from 2 to 3, but whatever, that's going to give me negative, and I'm going to take the absolute value of that to add it all together to get a total distance traveled. Okay? And once again, I am not going to really do the math for that. We've already found that the integral of this is 1/3 t cubed minus 7t squared, 7/2 t squared plus 10t. And I would integrate that from, I'll evaluate that from 1 to 2, which you can see that's a pain in the butt to do. And then I would do the same thing here, evaluating the same function from 2 to 3. And this should give me a negative answer, so I would just take the absolute value of it to make it positive. Now, another way that we could do this, a better way to do this would be just to use the calculator. And I'll show you how to integrate this on your calculator and use the absolute value symbols. And so if we did this on the calculator, we should get the same answer from above. Okay? And when we get together, I'll show you how to do that on the calculator. I don't think you need to use your calculator for any of the homework problems, but if you do, hold off and we'll do them together. All right, so let's do this last problem. One thing I want you to notice about this is that I am given the acceleration and an initial condition. So I want to know the net and total distance traveled from 1 to 5 feet. Well, the first thing I have to do is figure out what is the velocity function. So recall that the velocity is the integral of the acceleration. So in this case, velocity would be the integral of 2t minus 6. And so my velocity function would be t squared minus 6t plus c. And how do I find that c? Well, you have to use the initial condition. So I'm told that when t is 0, the initial velocity is -8. So therefore, from that, I can see that c is -8. So my velocity function would be t squared minus 6t minus 8, and that's my velocity function. So if I want to know how far I traveled from 1 to 5 seconds, if I just want to know the net, the displacement, I would simply integrate from 1 to 5, t squared minus 6t minus 8, and evaluate that. So what does that give me? T cubed over 3 minus 6t squared over 2 minus 8t. And I'm evaluating that from 1 to 5. And of course, once again, you can do the math on that. So what would that be? 125. T cubed is 25 times 5 is 125 cubed minus 6 times 25, 4 times 150 over 2 minus 40. And then minus 1/3, minus 3, minus 8. And you can figure that out. Okay, so that's how I would find, and this would be the displacement. if I didn't have a calculator to find the total distance traveled, I'd have to see when did the function, when was the velocity 0. So factoring this, I can see that this is t minus, can I get 6 from that? 4 and 2, can I factor that? Does that even factor? Negative 8, the only thing I give me 8 is 4 and 2 and 8 and 1. So that doesn't even factor. I have to use the quadratic formula. And that's just way too much trouble. So what I'm going to do is I'm going to integrate this from 1 to 5. And then I'm going to integrate the absolute value of this. And again, I can show you how to do that on your calculator. Okay? Alrighty, so what you should do is to go ahead and finish the pages 11 and 12 in your packet, and then we will go over this when we get together. I know this is a lot to cover, and it's probably good that we will go over this. It's good that you've seen part of it. Try what you can, and then we'll go over it when we see each other. Okie dokie? All right, I'll see you later.